What's up, 10-3? Hopefully you guys are all doing good out there and staying busy, keeping healthy. Today we got a quick lesson here on volume. And if you're trying to follow along in the notes, that's on pages 31 to 33. So first of all, what is volume? So volume is the amount of space that a substance or object occupies. So now we're kind of looking at like in 3 dimensions. The other thing we really need to make sure we understand here is what is the difference between surface area and volume? Well, the way that I like to look at it is I like to say, well, surface area is like if I gave you a box, that would be like painting the outside of a box, okay? That's going to figure out the surface area of that particular box. The other thing to remember about surface area that we talked about in those videos is that surface area is looking at an area. So that is in the second dimension. So whenever you're talking about surface area, you always end up with like some sort of unit squared. So centimeters squared, inches squared, whatever it may be. Now, if I'm talking about volume, well, what is the volume of that box? Well, the volume of a box is like if I took that same box and I stuffed it full of stuff. How much stuff could fit in there? Or like if I was going to fill it up with liquid, how much liquid could fill in the box, right? So this is like filling up a 3D shape. So we want to know like how much stuff could I put in that box? How much space could whatever I put in that box occupy? Or how much does that box occupy in general? Because now we're talking about looking at something in 3 dimensions, here our units are always going to be cubed. So maybe it's centimeters cubed, maybe it's inches cubed, cube kilometers, whatever it may be. Okay? So here is all of the different 3D shapes, we could look at. We kind of talked briefly about all of these in surface area, but we're going to strictly just focus on a few of these for volume. So the volume of any box is length times width times height. Now this will work for rectangular prisms. For our purposes, rectangular prisms and cubes. Can apply to other ones, but we'll just look at that. Volume of a cylinder is pi r squared h. The volume of a cone is 1/3 pi r squared h. And the volume of a sphere is 4/3 pi r cubed. And we should know how to, radius is half, and the height is always going to be like some sort of vertical measurement on those right shapes. So here it says, determine the volume of the 3D shape below. So if I'm trying to solve questions like this, I always go back and consult my formula sheet. Because I want to say, well, what shape is it? And then I'm going to write that formula down and then substitute numbers into it. So this right here is a cone. So I go to my formula sheet. The formula sheet says, well, the volume of a cone is 1/3 times pi times r squared times the height. Now, it doesn't necessarily say times, but when we have everything right next to each other like that, what it means is they're being multiplied. So looking at this shape, if I come to this, well, this 7 is the radius, and this vertical area is the height. So I just take those and put them into my formula. So I have 1/3 times pi times the radius, which is 7 squared, times the height. And really, I can just take all of that and substitute it into my calculator. Depending on what kind of calculator you have, you probably want to put that 1/3 in brackets. Make sure you put the fraction by itself. Otherwise, your calculator might go through BEDMAS in the wrong order. Then I'll hit pi. So really, when I put those next to each other, they're just being multiplied. So 1/3 times pi times 7 squared times the height, which was 18. And if I put that all in at once, I should get the volume is 923.6. So I'll go back to my screen here. So the volume is equal to 923.6. They don't give me a unit, so I'm just going to say, okay, whatever units that is, that's cubed, because I'm talking about volume. I've taken 3 different dimensions and multiplied them together. They could make that question harder, just as a side note here. If they give you this, if they give you the slant height, you can't use that in this formula. So you'd have to do Pythagorean's theorem to find the height, and then you could substitute into there. All right, another one. So it says determine the volume of the 3D shape below. Again, I look at this, I say, okay, that's a cylinder. And so I'm going to go to the formula sheet. The formula sheet says the volume of a cylinder is equal to pi r squared h. And I just need those numbers to put them in. So this 20 here is the height, right? That's the vertical height of this cylinder. And this right here, all the way across the circular top of this cylinder, is the diameter. And I actually, for my formula, I need the radius, so I'll divide that by 2 to get my radius of 10. So the volume is equal to pi times the radius, which is 10 squared, times by the height of 20. And when I put that all in to my calculator, I should get 6,283.2. And then I got to make sure I include my units here. So centimeters cubed, because I'm talking about volume, which is in 3 dimensions. All right. Another one, sort of a trick question here, says determine the volume of the 3D shape. Well, if I go to my formula sheet, this is just a box. So the volume of this box is equal to length times width times height. So here's the length, so 45 centimeters. We'll call this 15 right here. That's vertical, so we'll call that the height. And this should be my width. Now, if I'm looking at this, I have a problem because this is in centimeters, this is in centimeters, and this is in inches. When I'm trying to solve for volume or surface area, I want to make sure that I have a common unit. So what I'm going to need to do is change that 10 inches to centimeters. And so you can look at your formula sheet, and if you remember how to go from inches to centimeters, you just times by 2.54, which is 25.4 centimeters. That's my width. Now, because everything is in the same unit, I can substitute it into here. So the volume is 45 times the width of 25.4 times the height of 15. So when I multiply that all out on my calculator, 45 times 15 times 25.4, I get 17,145, and my units is centimeters cubed. One more basic example before a problem-solving one. So this says determine the volume of the 3D shape below. Again, I should just be able to look at that, say, okay, that's a sphere. So I go to my formula sheet, get the volume of a sphere is equal to 4/3 pi r cubed. So 4/3 times pi times the radius. Well, this one is actually giving me the diameter, so I'll divide that by 2. And the radius, or half of 42, is 21. So times by 21 cubed. So 4/3 pi times 21 cubed. Throw that all in my calculator. I get 38,792.4 centimeters cubed. Okay. When you're putting that in on the calculator, make sure that you put brackets around 4/3, just to make sure you keep your fractions separate. All right, interesting problem-solving question here. So let's take a look. So it says a sporting good company wants to design a package for their tennis balls. The tennis balls have a radius of 3.5 centimeters and will be packaged in threes with no space between them. So then it says find the measurements of one cylinder and one rectangular container. So what they're doing is they're taking these tennis balls, and the radius here is 3.5, and they're just, they're stacking them right on top of each other. And they're saying, if they all fit into a, let's say, rectangular prism, what would the dimensions be? Or if I take those same tennis balls, and they have the same radius, and I put them into this cylindrical package, what would the dimensions of that package be? Well, the one thing for us to know here is, well, if the radius is 3.5, all the way across this tennis ball would be 7. And they're saying, we're going to have the least amount of space in this package as possible. So the walls would probably be a little bit tighter than I drew here, but just for the sake of the drawing. So all the way across here is going to be 7. So, well, what does the width of this package need to be? 7. And because a ball is 3-dimensional, right, that's 7 no matter what way you cut this. So this here is also going to be 7. But what would the height of this be? Well, there's 3 balls stacked on top of each other, and they all have a diameter of 7. So 7 plus 7 plus 7, this would have to be 21. And for a cylinder, similar, right? Because I'd have 1, 2, 3 balls, all with the dimension of 7, diameter of 7. So the height there would be 21, and the diameter would also be 7. Or we could say the radius of that package would be 3.5. So that's the first question there. Next one says, how much volume will each container need to take up? Well, the volume for the rectangular prism, we know that formula is length times width times height. So if I just flick back here, well, the width is 7, the length is 7, and the height is 21. So I can just put those numbers in. So 7 times 21. So 7 times 21, I get 1,029, what is this, centimeters cubed. Well, let's see how much then the cylindrical container containing those tennis balls would take up. The formula is pi r squared h. So if we go back, the radius is 3.5 and the height is also 21. So pi times 3.5 squared times 21. So I can put that all in my calculator. So pi times 3.5 squared times 21 is going to give me 808, 0.1, or no, I guess we can round that, 0.2 centimeters cubed. So same tennis balls, but 2 different packaging. One's going to take up 1,000 centimeters cubed. The cylindrical package would take up 808 centimeters cubed. So then it says for the last part, C here, if the individual packages will be shipped in cubes on pallets, which container would be more efficient in its packaging? Well, I mean, if I am trying to save material or if I'm trying to create the most amount of possible, this one takes up quite a little bit less space, so I should be able to fit more in that large pallet. So that's most likely why we see tennis balls in their cylindrical package rather than their rectangular prism package. All right, so that's all the notes for homework. Again, if you don't have your formula sheet, copy one out, print one out for yourself, use that for your homework and your quizzes and your tests. Very important to use that as a resource for yourself, okay? So the homework, if you want to do some practice questions, is on page 34 and 35. That's homework 8 on volume. If you run into any triangular pyramids or prisms, just ignore those and do the rest of the shapes. That's what the quiz will be on. And then when you're ready, go try that quiz. Okay, thanks for listening, guys. Have a good one.